Hey there, YouTube. It's Barry, KK7JXG. Got a quick one for you. A little project, the latest project, off the bench. And I think most of you know I really love this little guy, the FX-4CR. Little 20-watt radio, ultra portable. And you see it here in my POTA configuration. And when I run POTA, I often like using these guys. These are my Heil Pro Micro headset, and I use it a lot with my 991A, but on the FX-4CR, no can do. There's a problem with using it together. The Heil uses a dynamic mic, and the FX-4CR is designed to use a condenser mic or an electric mic. And so what I did is wanted to make a little circuit here to buffer the two. This is this little guy here. It's a preamp with a PTT button so that I can use my headset. And the reason you need one of these guys is that, for those of you that don't know, a dynamic mic is basically like a speaker. It's a diaphragm and a coil, and when sound waves hit it, it moves the coil and induces a voltage on the line. The problem is that voltage that it generates is really, really low. Probably I think I measured this 2 to 3 millivolts versus 20 to 30, maybe 40 millivolts that you would typically modulate on a condenser microphone. So it's not only got low output, in this particular case, this dynamic mic in the Heil is low impedance too. It's roughly 600 ohms. And the FX-4CR microphone is around 2 kilo ohms. And with the firmware that I'm using, which is the F5BUD V2 version of the firmware, it actually does a check, and I believe it sees that microphone 800 ohms, and it thinks that, hey, there's maybe a short or something, so the radio won't even power up when the mic is plugged directly into the radio. So this circuit does two things. It presents a high impedance to the radio so that it starts up, and then it also takes that 2 to 3 millivolt signal from the dynamic mic and boosts it up to the appropriate level that the radio is expecting, all the while blocking any of the DC from the radio from getting into the dynamic mic. The mic's not made to carry current across. It's a voltage-inducing device. So I initially looked around on the web and didn't find much out there. I found a lot of little preamps, but they were mostly audio related and a little more complicated than I wanted to do. What I got here is a real small circuit, and it's a single transistor, 2 capacitors and 2 resistors. And you could probably wire it right to this little switch that I got for the PTT. These are little Amazon momentary switches. And I did have a previous version that just put all the components on the back of this and wired right into the mic line. But I wanted to get a little more robust here, get a little case. I didn't like the heat shrink look. So I went with something a little bit bigger. And what I did is made use of these little breakout boards on the tip ring sleeve jacks that I'm using for the microphone. So with these guys, it looks like this when you solder it in. And since the mic on the Heil is only a tip and a sleeve, and these are tip, ring, sleeve with 2 switches, I remove all the contacts from the connector that I don't need, and that provides a base to solder the other components. So everything is soldered to this. So the transistor, the capacitors, the resistors are all tied to this. They fit into the case real nicely and produce the appropriate signal and keep the RF off of it. I did, in my testing, I have a little capacitor that should block a lot of the RF off the mic line, but you know, your testing may vary, but I wasn't getting much RF on that. I know they're problematic, and some people put ferrite beads. I didn't need that on this, but your mileage may vary. And again, my schematic is online. You can use it if you wish, but I'm not responsible for anybody frying their radios. I know it works for me, and it's a pretty simple circuit. It's basically just taking the little bit of DC bias voltage that's on the FX-4CR mic line that is used to power the electric mic, the condenser mic, and the transistor can operate off that. Basically it scavenges the power off of that bias voltage that's on the line, and then powers the amplifier and amplifies the signal from the dynamic mic, and it sends it back to the radio. All pretty simple. It's fairly basic electronics, but it's been a long time since I did it, so I didn't find anything out there, so put this one together and put it out there for you guys to look at. But it is a pretty simple circuit. I currently have the gain to match the original mic, so it's about a 20 to 23 dB boost on the dynamic mic, and that allows me to set the mic gain settings on the radio the same as the stock mic. So when I switch back and forth between headset and mic, everything remains the same. I don't have to change anything out. You could, and I was going to experiment, but I didn't want to have to remember, you could increase the gain on the amplifier circuit here so that you get a little higher voltage output from this, so that you can turn down the gain in the radio. Don't know how that would work. You know, less gain here, more gain here, and that way I was thinking maybe it would overpower any RF interference on the mic input side, just because you have a higher signal level coming in, and you can turn that down. But again, I wanted to keep it simple, not have to remember that the headset, I need to turn the mic gain down quite a bit. And I know on at least the V2 version of the firmware, there's quite a bit of range for mic level inputs. I think it goes from 0 to 200. So with the stock mic, I set that to about 130, so just above 50% level, and that's right where this is sounding good as well, with the dynamic mic and the gain that I have set with the values that you'll find on my GitHub page. A couple notes on the case design is it's pretty simple, but I did get a little lazy on it. The circuit board slides in. Let's see, I got an empty one here. But the circuit board slides in on these grooves and then snaps in there. And then the cap actually supports the switch and holds the circuit board in place. However, I got lazy. I didn't design it to be a snap closure or a screw to hold it down. I just pushed it all together and put a couple drops of crazy glue in there, because I'm not going to pull this apart anymore. Not serviceable on my design, but you may want to change that. Also, I elected to go with a corded end versus sockets on both ends. You know, it could be a little more compact if you put a jack connector on each side, but I did this for mistake proofing. I know the mic connector will always go in one end, and the radio will always be on this pigtail. I didn't want to inadvertently, you know, come back 6 months later and, oh yeah, this is the way it goes together, and plug the radio into the mic side and vice versa, and, you know, possibly bad things happen. Again, I'll put a link to my GitHub page. You'll find this and, you know, my antenna projects and stuff there. I think most of my stuff is there. It's not, I don't have a big library, but the stuff that I think is valuable or at least useful to maybe one more person than me is there. So you can give it a try, give it a go, and if you don't like it, well, you're out, what, $10, so, you know, not a big deal, but, you know, I really like using a headset when you're at the park, and all the ambient noise. It lets you listen in a little better, at least for me and my ears. So that's it. I hope everybody is playing radio. We're having some great weather out here in Arizona this springtime, meaning that this is the junior summer, where we've been in the hundreds since, let's see, late February. So we hopefully get a little cooling trend and we'll get out to the park again. But most of our radio's early in the morning, and hopefully everybody else has got a nice spring and playing radio, and I hope to hear you guys out on the airwaves. So with that said, I'm gonna say farewell. 73. This is KK7 JXG. Till next time, I'm out.